Welcome to a talk about FHIR Shorthand. This is a very new project, so I'm not going to be able to show you a fully functional system, but we have gotten to the point where we've done some language design and early implementation. So first of all, hello, I'm Mark Kramer. I work for FHIR. It's a company in the US. Chris Moselle is my co-lead on this project, and he couldn't be here. I drew the lucky straw, so he got to go to EMEA. But FHIR, if you don't know, it's like a R&D center that works for the U.S. federal government. We're a non-profit, and we work in the public interest. So we don't work for the government per se. We don't work for profit. We actually work for the people and do things that would be of use. And we're behind a bunch of things, projects that you may have heard of or used our code. Cynthia is the patient simulator. We have an implementation of OpenID Connect that many use in the FHIR community. Inferno for testing. We have an IG for oncology, for cancer care, MCode, and a few other projects that you may be familiar with. So we've done quite a bit in the FHIR community over a period of time. And today I'm going to introduce FHIR Shorthand. Shorthand is a language for defining IGs. I'll explain why, I think we need yet another tool for doing that. It is a new project. We just started in September. At the last work group meeting, it's sponsored by FHIR Infrastructure work group. And potentially, it may be a standard in the future. We don't know yet. The other thing I want to point out is the word community there. We're very interested. It's not in inputs and participation from others. It's not a MITRE-owned thing. It's an open source project. And we've already had very good participation in the designing of FHIR Shorthand, and we hope later in the implementation as well. Now, we came up with this name to be descriptive, but it turns out it's kind of a fishy name. Turns out if you look at FHIR and shorthand, you get FSH, and then that spells kind of fish, and the file type is fish, so people started making little jokes about this, and it was kind of like a tidal wave, and more fishy jokes came out. So now our compiler, which chops up the fish, is called Sushi, which is a self-referential acronym for Sushi Unshortens ShortHand Inputs. That wasn't ours. And Hatchery is another, it's sort of an anti-compiler, which takes structure definitions and produces FHIR Shorthand. So Sushi goes one way from shorthand to structure definitions, and Hatchery goes the other way. So we might call it fish, we might call it shorthand. I want to call it shorthand because fishy can be a little fishy. Regarding the community, we have calls each Thursday morning, not this Thursday morning, that would be in 15 minutes. At 9 a.m. Eastern time, we also have a repository in HL7 where we're keeping the design documents and the language specification. And we have a growing reference implementation of the Sushi compiler, which is in another GitHub repository. And you'll also find some discussion on Zulip. So we really are trying to engage everyone in the design because it's hard to do it right. So why do you need another FHIR profiling tool? Well, we already have spreadsheets and Trifolia and Forge, and many people even edit structure definitions by hand. So why do you need it? When you're doing a FHIR IG, and this is my experience now, having done 5 or 6 of them starting several years ago, I find that revision is the most important thing that you do when you do an IG, constantly revising things. And why? Because, you start with a first draft, and then as you go, you kind of better understand what you're trying to express. So you're iterating on the design, exploring design options. Then new people come into the conversation with new ideas. They may change the scope. You take your IG to a connectathon and you learn a lot of things, and then you want to roll those changes back in, and you learn lessons from the early pilots, and you go through the ballot process, and you get ballot comments, and FHIR itself evolves, and the practices around FHIR evolves. If you're based on other IGs, they can evolve as well. And people change their mind and forget what they said last week and come back with changes. The result is many, many iterations. So the tools that you use for IG creation need to be very agile in order to go through these cycles of iterations. And I'll give you a specific example, because we worked on this IG called M-code for minimum common oncology data elements. And we kept the source code in a repository, and you can do stats on the repository, and there were 472 commits and 3,400 changes. And the little graphic that you see is actually each blue line is a file that's changing, and you see the various participants exchanging files and checking things in, and you can see the heap of changes that are happening there. I think we're in kind of Christmas vacation now. This is between October and March. We've had further changes which are happening because of the recent ballot cycle. So you can see all the changes that went in, and I don't know how we could have gotten through this without having a very agile tool. So that's really the motivation behind FHIR Shorthand. And it actually is a second generation of this type of tool. We started with something called Simple for clinical information modeling and profiling language. And Simple is very similar to Shorthand, or should say that in reverse, I guess. The Simple tool has been used for many IGs, actually, that have been balloted and used. And it's mature, it's on version 7. So it's been around the block a few times and has a lot of features. The thing about Simple is that it was built around logical models first. So it didn't really have anything to do with FHIR when we started out. And this was several years ago, before FHIR really exploded. And over time, we kind of incorporated more FHIR aspects, but we still, at the core of Simple, had a logical model and the idea of mapping that logical model to FHIR. And we've discovered over time that the need to do the mapping and having a separate logical model is actually a disincentive for use in this community, because it gives you another thing to think about that is in an abstract space outside of FHIR. So when we started working on getting Simple adopted, we found that this was a problem. So we rebranded, rethought, and came up with a simpler idea than Simple. So actually, Shorthand is actually more functional and simpler than Simple. So it's based on FHIR. There's no logical model other than the FHIR resources, and it's all about creating the artifacts that you need in an IG. So there's no different model or mapping. So that's really, we think we know what we're doing with this because of the previous experience. It's dangerous. So FHIR Shorthand is a textual language. It has a grammar which is designed to express exactly what you need to do to create a profile, or create examples for the profile, or create operation definitions for the IG. So the way I look at it is that Shorthand expresses the intention and not the implementation. So if you want to fix a value, you just say fix a value. You don't have to worry about how that's done within a structure definition. And in fact, if the practice of how you implement a fixed value changes, which it has, now the practice is evolving towards using patterns. The Sushi compiler will take care of that. and it will consistently produce a structure definition out of the intention statements that you've put into FHIR. So if your shorthand is just what you want to do, Sushi will take care of how you do it. Okay, that's the idea. So why text? So in general, complex projects, anytime you do them, you're using a language, you're using a programming language, and you can put the language, you can put a text file under source code control and do differentials. So the diffs between one version and the next of a text file can be simple or they can be complicated. If every statement in shorthand represents an intention, every change represents a change in intention. So the diffs are very meaningful, okay? If you took an XML version of a spreadsheet and another XML version of a spreadsheet and you change one thing, it's going to be a real mess. So you get meaningful differentials. And really, we think it's 10 times faster than any other method that is available in terms of producing a finished artifact. So I'm going to do a little grammar overview, and I hope this is big enough to read, but I want to focus your attention to give you just a sense of what the grammar looks like. It isn't, I don't, in 40 minutes you're not going to learn the whole grammar, but so this is a block, the whole thing is a block which represents a profile on medication request, okay, from US Core. And it starts off with a little header, I guess, of keywords, which states the name of the profile, the parent for the profile, the ID for the profile, the title, and a description. And I shortened the description a bit. So that is a little preface which sets the stage. Then comes a set of statements, and they don't have to be in this order. I just arranged it for clarity in this order. These statements can be in any order. Each one of the starred statements is kind of a bullet list of the constraints that you're applying to the parent profile. The first line here is just a list of things. It's almost cut off, but there's an MS out here which represents must support. So these are all the must support elements that are specified inside this profile. The second and third lines here are simply cardinality constraints. So you're making two things required. And then as you move on, there are some things in the parent profile where they give you multiple choices, and we are specializing those choices and restricting those choices within the profile using a keyword only. So the reported is a choice element, which we're restricting with the word only to a Boolean or a reference to US Core patient, or US Core practitioner or practitioner role, US Core organization, a related person. So actually two things are happening here. We're removing some of the types, and we're also specializing some of the types. So we're taking patient, and we're saying patient has to be a US Core patient, and it has to be a practitioner is now replaced by US Core practitioner. And then the whole list of things is smaller than the original list of things. So that's the way that you do a type constraint. And we do the same for medication, which is only a reference to US Core medication or codable concept. The subject is only a reference to US Core patient, and the requester is only a reference to this list of items. And then the last kind of statement here is a binding. And what we're doing is we're binding the medication codable concept and taking it from the US Core medication codes, and that's an extensible binding. So I've explained, the half a dozen, 8 or 9 things that you want to do in this profile in 8 or 9 lines, right? So that's kind of what I meant by, here's what I want to do. I just state it in this language. Now, this will look a little bit strange to you because you've never seen it before. How many grammar elements are there? Well, there's enough so that it would take, a day to learn them. But not a week, not a month. It would take probably a good day to become familiar with them. The order is not important, and you can wrap the lines, you know. No, I just did it for this purpose. I mean, the other way to do, you could reorder them any way you'd like. So, yeah. No, they can. They're imported. Yeah. So you declare any import, and then you can use them. So as long as they can be referenced, they can be loaded. Yeah. And we're using npm packages. So that's yeah.
Can you do round trip? Can you transform?
Well, not yet, but I'll get to that.
And then if I would have more value sets that I would be needing to add is also additional lines.
Yeah.
Like
So this is just one part of of what could be a much larger file. You could do all your profiles in one file, or you can divide them into files. So just like the white space, this is up to you, or up to, you know, how the order of lines. You can have, like right under it, you could have the US core medication. And the value sets can also be defined in shorthand. I'm not going to show that because that's not implemented today. This just refers to a value set, which is defined in US core. So actually, this is, if you imagine, this was actually, we just took US core to play with, but so pretending we're defining US core, this is internal to US core. This could be a URL. So let me go on so we have time. I want to talk about slicing. And those of you who are in the US who are as old as I am might remember the Ginsu knife commercials, the very famous late night commercials, the miracle knife that cuts through anything, cuts through trees, cuts through tin cans. We call the way we do slicing Ginsu slicing to keep with the fish, you know, and the sushi and all that. And because what we're doing is actually automagically determining for you, if we can, what the discriminator is, what the discriminator path and the discriminator type is. And if you specify the slices and there's a fixed code that's different between each of the slices, then we know exactly what to do with the slicing. We also give you a way, so this makes it much easier. It makes it so you can have a single statement that achieves your slicing. There's also ways to override that and specify explicitly how to do slicing. So I'll show you a little bit of both of that. So here's a slicing example just with the basic grammar. And you'll notice again, this up here is just the declaration of US core practitioner. And then down below you'll see some, like this bulleted list of constraints. And then something we haven't seen before, which is the contain. So identifier, we're saying identifier, which is an array, contains a national patient identifier, 0, 1, and it's must support. So you can what we're doing here is actually three things. We're saying this array contains this item will be 0, 1, and it'll be a must support. Then we're defining what the NPI is right in line. So that we're referring to this NPI, which doesn't yet exist, and this is also order independent, but the identifier of the NPI dot system, you can kind of feel what this, we're using this name here as the array indicator in identifier, and then we're setting we're just saying the system is must support, then we're setting it to a code system, and then there's some special grammar happening here. There's a little caret, that's this upper thing, circumflex, and that is an escape character which takes you to the structure definition. So there's metadata associated with that NPI, and this actually you can think about going up to the metadata in the structure definition, kind of punching out of your current dimension, going up to the structure definition. And in the structure definition for this element, there's a short description, and this is how we're setting the short description. And that allows you full control because you can get to any element in the structure definition with this grammar. Extensions work almost the same. Well, here I'm just pointing out the metadata, which applies to US core patient. So all we're doing is we're setting things like the publisher, the contact information, the jurisdiction, and so forth, using that escape character. And then the extension happens here where we have a contains statement. We're saying the extension array contains these three things, right? The race, the ethnicity, and the birth sex. And we're saying what the cardinality is and whether or not they're must supports. So that makes slicing quite easy. And of course, we haven't defined, if we're imagining we're doing US core, we haven't defined these extensions yet. And the way we define the extension, hold on just a second, is very similar. We declare there is an extension called US core birth sex extension, has an ID, title, and description. And then extensions have either values or other extensions. And we're just saying the value X is only a code. And the value code comes from the birth sex value set. So this is, again, a binding using from, and only setting, constraining the types. And you had a question. Yeah, yeah. Right. Well, although these are on different lines, it's really just one line because it's like, declared with one statement. And we just use the starts to kind of, I don't know, looks good. We were trying to, boom, 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 right? And this is just one line. It says it contains race and ethnicity and birth sex. That's what it says. Yes.
How do you add, so in current structure definitions, it is possible to add business logic using FHIR path. So declaring one extension could be ruled that it should be
Right.
in some
Yeah.
other path.
So those are invariants.
Yeah.
And so I haven't got this in this presentation, but if you go to the design documents, you'll see how we declare invariants. And basically, it's a very short declaration. It's instead of the word profile, you'll have the word invariant, and it'll have the properties of the invariant as keywords. Then the way you bring them in to this structure is the word obeys. So you could have an element that obeys, and then you give the ID of the invariant that you've defined. So, the name obeys whatever, right? And if the invariant doesn't belong to a single element, you just have a constraint at the very top that says obeys something, and that means the whole thing obeys this invariant. So there's actually a lot of features in there. Now this is this is one of the things that really gets me excited about shorthand because I've had this problem before. This is where I'm trying to define a domain-specific IG with a national IG, okay? And single inheritance is a problem here because, well, I'll give you the example. If you have observation, the resource, and then there is a US lab observation, and then the genomics group says there's a genetic sequence observation, and maybe the Netherlands have a lab observation as well that uses something else. I don't know, I'm making this up. So now I want to have a US sequence observation and a Netherlands sequence operation profile. So you got to make a choice of which you inherit from. And if you inherit from this, you don't get that. So we have this concept of a mix-in, which is simply copying constraints but not inheriting them. So we can inherit, for example, from genetic sequence observation and then mix in US lab observation. Or over here, we inherit from genetic sequence and mix in the Netherlands lab observation. So this is going to be something which is really, really helpful. And it's just another keyword, mix-in, and you can list the mix-ins that you want. One of the things about US core is that the metadata in every profile is almost exactly the same. So you set that up as a inheriting from domain resource, which has all the metadata, and then you mix it in to every class you create, and all that metadata is set for, it's the same jurisdiction, it's the same publisher, so this makes life extremely easy, and there's no repeating yourself. 320, right? Another thing I'm excited about is instances. So usually we create the structure definitions, and then we switch over to our JSON tool, and we start doing examples. And then we revise the structure definitions, and we've got to go back and we have to change the examples, and they're all out of sync because they're not in one environment. It's kind of like one after another. I see some smiles of recognition, right? You've done this before. So in the same file, or in a different file, depending on how you want to do it, but suppose you define US core patient. Right after that you say, I want an instance, patient example 1 or whatever. This is an example. Then the same syntax, the same grammar can be used to create your example. So usually that's just fixed values, and that's the equal sign. So, the identifier use is usual. Maybe I cut that out, but this is a code. The hash sign just means code. And the type text here, so you see all the fixed values that are happening. And if you can read this, it's kind of like pseudocode. You can understand, given names, that it's all pretty obvious. I hope it's obvious. If it's not obvious, then we've kind of failed. So this is good because everything that's fixed in US core patient, the whole structure, any extensions you've defined are automatically in the instance. You don't have to create those extensions in the instance, the birth sex extension and so forth, the ethnicity and the race. That's already there. It's inherited from the parent class, which you're instantiating. And then you just do a fixed value where you want the fixed values, and you've got your examples. So that's a brief tour of the grammar. Now, this is a very fishy picture of the overall flow. So I'll talk about this in a little bit, but what you do is you set up a folder. We're calling them fish tanks with all your fish files, okay? And one fish tank corresponds to one IG, okay? And it'll become an NPM package at the end. So you have a bunch of fish files. You can arrange them like you want. You point the Sushi compiler at that folder, and it slices and dices it to end up as a set of profiles, extensions, value sets, examples, and operations. This is, in turn, is fed into the regular HL7 FHIR publisher. So this is just setting you up for the publisher. Then the publisher runs and gives you this menu of all the stuff that someone can use from your IG. It's literally like a menu of all the profiles and so on and so forth. So we're not rewriting this. We're depending on, the normal templates and everything. We're defining this language and building a reference implementation of the compiler. And I had a question earlier about round tripping. So it will be possible to take anything that is generated here and recreating the fish files. Also, if you have existing structure definitions and you would like to adopt using FHIR Shorthand, you can use something to be written. Anyone would like to write it, please volunteer. We're calling hatchery, which takes the row and creates fish files out of it. So you have the whole life cycle of FHIR Shorthand. Yes?
Can you go back 2 slides, please?
Yeah. This one.
When you mix in, do you copy or do you refer to?
Copy. So it's copied at compile time. So if this changes and your source code doesn't change, but this could change, it could add a constraint, change cardinality or something. When you run Sushi, it'll import that, and create something which is fresh. Fresh, you don't want day-old sushi, right? Yes, the mixin can fail. So when you run sushi, there's lots of ways that you can get an error message. For example, if you mix something from an observation class into a condition class, that doesn't work. The rule for mixins is that they have to inherit from the same class, or they cannot inherit from different classes. They can't contradict each other, right? Right. So if you try and constrain something in the mixin that doesn't exist in the class, it'll create an error. Yeah. So the documentation is up on our GitHub, okay, and it's evolving. So we are making changes in our Thursday morning conversations. We find out new things when we implement it, and we update these documents. And they may lag a little bit behind our conversations. But I'll give you the reference at the end. Yeah.
When you, on the next slide, when you talk about the test data, the sample data,
Yeah.
I had a similar issue, but not creating one example at a time. I wanted to create 78 resources at a time. It was for prescribing a drug for the next 3 weeks, for taking this 3 times per day. This makes a bunch of resources that are very similar. So one of the ideas was to put some syntax there that you can put some variable values there. Is that also something that you work with?
So that would be an issue of inheriting an instance from another instance, but we haven't done that.
Or you can still put some syntax there, like you say name family, and you can put I don't know, or actually
Yeah.
the gender field, you can put random there.
Yeah.
That.
Another idea is macro hunks of codes, like just have an anonymous hunk of code through alias. I didn't talk about aliases, but we have aliases. But we have not decided to support that at this point.
Sorry, and final question.
10 minutes left.
For the things that,
Yeah.
we can do, which is
Yeah.
do you have some sort of, here's what can be done
Yeah.
with FHIR, this is where we are now?
Yeah, I'll show you that. So it's very limited right now, and we started only a few weeks ago. So it's text, right? So let me just get to the end. You can use any text editor. Our favorite in our team is Visual Studio Code. And there's a plugin right now. It's pretty primitive. It just colorizes the text. The examples with the colorized text were from that extension to VS Code. So if you're interested, if you load any file that with a fish extension, FSH extension, it'll prompt you for the extension and just load it in. It's amazing what software can do these days. So our status. So actually, we have a pretty long roadmap, and we've been coding for about 3 weeks or 4 weeks. And it's actually a very, very nice, my colleague Chris has done an excellent job in laying out the framework, a very solid framework in TypeScript for sushi. So we've got many types of constraints. We have value set bindings. The next things we're working on are extensions and slicing, then mix-ins and variants, metadata, and so forth down the line. So, that represents only a few weeks of work. So, yeah. No, the grammar development is actually way out in front. So we've talked about how we're doing all this, and we haven't really talked about this yet. But we have ideas here which come from Simple, the precursor language. Yes.
Plans for using the implementation guide resource, which could be some kind of wrapper?
We haven't, but it would, if that's the practice that comes to be for implementation guides. Like right now, the thing that we would want to do first is a capability statement and automatically generate the capability statement from all the things that you've got, and then maybe that hasn't been worked out yet. So the front matter, we call that the front matter of the IG and the various text files. We're not helping with that. you still have to describe your workflows and so forth. And those just become other files within the fish tank that, you know, get incorporated into the IG. Oh yeah, you just put them in the folder. So then it will be incorporated. But we haven't gotten to that. So I just leave this up. This is a syntax summary. This is what you can do now. You can actually, it's very easy. This is like 4 minutes of you know, it's very easy. It's just very quick. Download Node.js. Do one npm command. It downloads all its dependencies. Then you can. There's some sample files available on the GitHub site. You can play with those. You can examine them. It's very limited capabilities right now. And you run Sushi. You can actually change directories into the directory where you have your fish files. So you can be in that directory and just say sushi dot. Exactly. I think that's it. And then the other, you know, the only other thing is that we really would like people to get involved. For those of you in the international community, as many of you are here, we have designs on internationalization, so you can make a language-specific IG. So because it's strings, you can strip the strings out, you can isolate them, translate them, and then incorporate them. So that design is not fully done, but it is our intention to have multilingual or localized IGs. So same content, but all the text strings would be translatable. So it's quite a big scope, and we do need, we would like help. Any other questions before we're done? 4 more minutes, I guess. And if you didn't get a t-shirt, I think there's a couple left. And you have to wear it around during the ice skating party tonight. Yes?
Thank you. So I'm going to provide some validation logic for this profile summary. Do you know what the basic profile is in the database? When I write this differential, yes, I probably mistype the name of element.
Right. So there's a lot of things that can go wrong when you're free typing your requirements for the profile. You could reference something that doesn't exist. You could misspell an attribute that you're trying to constrain. So all these are error messages that you'll get from the Sushi compiler. And by the way, because we're writing in TypeScript, it can be run locally on your machine, or it could be hosted. So it's very flexible the way that you can deploy this. So error messages will come. We never were able to do this in simple, but in shorthand, we'll be able to point to the line in the file that's that's guilty of the error. So it should be easy to find your errors. And you know, usually when I do this in simple so far, I'll do a whole bunch of profiles and changes and so forth. Then I'll try and compile it. I look at the first error. There'll always be some errors. I never get that lucky, and so I fix it. And I forgot a capital letter or something in the name, and you go through, and then it finally compiles. It produces all the profiles, extensions, value sets, and so forth. And then optionally, you can run the time-consuming IG generator, publisher. And I sort of rarely do that. Once it's compiled, I know it's pretty much intact.
How do you manage dependencies between versions of FHIR or
So every IG, every fish tank specifies a version of FHIR. We just started thinking about multiple versions of FHIR in one fish tank, but we really hadn't planned for that. It's just that DaVinci is doing that. So we don't know how to do that yet. And then the dependencies on other IGs are through their canonical IG, and you can use the vertical bar to indicate the version. So I think an earlier talk was by Graham about the NPM, which is a miraculous piece of software, which I love. And it makes life and version dependencies much, much easier.
So you're going to use NPM to install.
Yeah, yeah. So we actually use npm already to install Sushi. This is amazing because it pulls down, 25 different dependencies just for the compiler itself, right? Just the code in the compiler, not other IGs. So it's just in conclusion, what we're trying to do is create this tool. Yeah, I'm finishing up. That's my concluding statement. Is create this tool that's really friendly and fun to use. And I think it will be very productive. And it could work with other tools too. I mean, if you circle back to Forge or you circle back to Lantana's Trifolia, they're thinking maybe we should store our profiles as shorthand instead of storing them as structure definitions. I'll tell you something. I counted, just to give you an idea there. This is what happens when you run it on, I think it was the medication request, the one that we went through. 13 lines of shorthand became 5,139 lines of JSON, structure definition. So that's a good compression ratio. I'm pretty proud of that. What's that? So give it a try, and thank you very much.